Welcome to this video cast, and this is the fifth in the series of video casts for the module which is Physiological Profiling, Strength and Power. And in this one we're going to look at muscle mechanics and the idea of the physiology of force generation. And so this is really important, particularly leading into your understanding about strength and the way in which we assess strength and power, but it also feeds back in terms of understanding a little bit more about what happens when we assess mechanical power. So for example, it connects very nicely to previous video casts on anaerobic power testing, on anaerobic capacity testing, and even agility-based testing. So what are we going to cover? Well, throughout the course of this session, we've got four key elements that we want to focus on. The first is to evaluate the properties of skeletal muscle that are involved in the generation of force. So it's a little bit of kind of a reflection, maybe some stuff that you've already covered in terms of just the basic structures that are involved in the generation of force. Then we're going to look at this in terms of an integrated system. So how do those key components in terms of the structure of our muscle fibers, and in particular what we call the sarcomeres, which sit within the fiber, how do they contribute to the development of force, and how is that very much an integrated system? And then we're going to go quite deep into the connection between the central nervous system, that is in this case the motor unit, and the actual sarcomere itself in what is called excitation, contraction, recoupling. And how do those two elements connect together to generate force? And then finally, we're going to look at these in an applied setting and actually see what happens when we actually do assess strength across ranges of motion and the like. So let's start with some basic first principles in terms of just thinking about muscle actions. And we'll start off with just getting back to understanding a little bit about what we mean in terms of muscle actions and muscle types. And there are three basic muscle action types. There are those which are concentric, those which are isometric, and those which are eccentric. And if you think about it very logically, under a concentric based action, the muscle is by definition shortening. And in fact, what we have here in the equation, which is taken from Comey, is a tremendous little section here from a book that was published. It's defined as being a positive generation of mechanical force. And so what you have is that classic idea of shortening. It accelerates. Whereas under eccentric loading, and what I would like you to think about is reflect perhaps on what we've touched on in videocast 4, which is change of direction and the assessment of change in direction, is we refer to the notion of when we change direction that there is a point of deceleration. And that is because the muscle is under a state of elongation. And these are defined as negative external mechanical work outputs. So under eccentric loading, the muscle is actually under a state of lengthening. And so what is happening is we're getting decelerational forces. It's like putting the brakes on. So if we are, we've got a really heavy load. Okay, so imagine that I've got a heavy load. I'm doing a bicep curl, but I've got a really heavy load, and I'm trying to stop my arms from extending. And what I'm doing is I'm resisting the force. That is by definition, I'm applying a deceleration. I'm slowing the rate at which that bar or those dumbbells fall. By definition, the muscle is under a state of eccentric loading. If, on the other hand, I just let them fall, they're accelerating. I don't put a resistance on. That is concentric, as would be if I just go from a state of extension to flexion. And then sitting in the middle, there is this notion of isometric. And under isometric, there is no change in muscle length. It's a state of fixation. And in many ways, it's worth recognizing that most of the muscle activity that we undertake actually probably has a component of being concentric, isometric, and eccentric. So if you think about walking and running, in walking and running, there is absolutely a concentric phase as we accelerate into the ground. We have a deceleration as we hit the ground, and then as we start to drive off, it becomes concentric. But in the middle of that, we've got an isometric phase. There is actually a point in that action where there is neither a deceleration or an acceleration. Very short period of time, but it is an isometric phase. So fundamentally, Moving into subsequent videocasts, so that'll be videocast 6, where we look at assessment of strength, and also videocast 7, where we look at the use of isokinetic dynamometry. We know that these muscle actions are important. We know that they apply to almost all activities that we undertake. Therefore, we have to be able to find ways of assessing them. We have to understand the way in which the muscle works under these specific conditions.